Hi, in this short video I'm going to go over the last part of Chapter 11. And Chapter 11, remember, was on univariate analysis. And in this last section we're going to learn about the normal distribution and some exploratory data techniques. And I wanted to mention that there are quite a few things in my courses. Let me pull it up real quick. If you look at the readings and videos, you've got a lot of handouts here. You've got an empirical rule handout, normal distribution handout. So I want to make sure you take a look at those in terms of how you're going to work on problems for this section. So let's take a look at the standard deviation and the normal curve. So the standard deviation is used extensively in inferential statistics, and it's used to estimate how closely a sample characteristic is to the corresponding population parameter. And the normal distribution uses the standard deviation as a ruler. The normal distribution characteristics, bell-shaped and symmetric, mean, median, and mode are equal and located at the center of the distribution, and a fixed proportion of data lie between the mean and any fixed point on the curve. So the empirical rule, and again you have a handout for this. This is not covered real well in your book, so I created a handout. About 68% of the cases in distribution, will, if it's normal, will fall within one standard deviation of the mean. 95% within two standard deviations, and 99.7% within three. And here's a nice picture that demonstrates that. So about 34% between the mean and one standard deviation above and below, another almost 14% between one and two standard deviations, and then a little bit more than 2% out here in the two extreme tails. Now a z-score measures the distance in standard deviations of an observation from the mean. So we take the data value we're interested in, and we subtract the mean and divide by the standard deviation. And so z-scores are going to run from, let me go back, they're going to run from -3 to +3. They could be more extreme than that, but generally we'll find z-scores within that range. So let's try a couple examples. If you know the mean of a distribution is 100 and the standard deviation is 20, calculate and interpret the z-score for these numbers. So we're going to take 115, we're going to take 115 minus the mean, which is 100, divide by the standard deviation. So a score of 115 is 3/4 of a standard deviation above the mean. Now notice this number is below the mean, so we're going to have a negative z-score on this one. So we're going to take, oh I'm sorry, I did 80 and this says 75. Let's focus on 80. 80 minus 100 gives us 20, -20, and divide by 20 gives us -1. So this observation is one standard deviation below the mean. Ignore the 75, focus on the 80. All right, exploratory data analysis is becoming familiar with the data, and rather than just summarizing it by one or two statistics, and we make some pictures and different calculations. So one calculation is called a trimmed mean. We take away a certain percent of outlier, a certain number of outliers or percent of cases. So 5% mean, we calculate it after the bottom and the top 5% of data are removed. The mid-mean uses only the middle 50% of the data. A new display was created called a box and whisker plot, and this is what this looks like. And this allows us to see the minimum, Q1. Generally, the median is in here as a line, as a bar in the middle of somewhere in the box, Q3, and the maximum. And it's named after, we use a 5-number summary, which is the min, Q1, median, which is Q2, Q3, and the max. And John Tukey was a statistician who developed several EDA measures. And we use those 5 numbers again, min, Q3, Q1, Q2 or the median, Q3, and the max to create the box plots. And we can compare data sets with box plots. That's a nice advantage of using we call this box plot side by side. So in this example we can see the western states have a much higher variation in their murder rates. Remember that Q1 to Q3 is a middle 50%, a lot more variation in the western states. But the average actually for the southern states, it appears to be higher, smaller IQR. So picture visualization or data visualization helps us to really understand data better, and we present data to an observer in a way that provides insight and yields understanding. And then a summary of what we covered in this chapter. We talked about data management, spreadsheet, statistical software, database management. We talked about analyzing and presenting in tables and also frequency distributions. Visual displays, bar graphs and histograms, pie charts, line, time series. We also talked about the box plots over here. Measures of central tendency, mean, median, and mode. Measures of dispersion and variation, range, interquartile range, standard deviation and variance, and then a little bit on exploratory data analysis, the trimmed means, and also the box plots. So that's the end of the univariate analysis chapter. I think that this short little video here, in addition to what we covered in the last 2 weeks in the weekly chat, you should find helpful.